All right, guys, Mr. Antonucci here, and in this video we want to talk about how to get the derivative of e to the x and natural log x. Now, up to this point, none of the rules that we've looked at or developed so far allow us to find the derivative of an exponential function or a logarithmic function. So what we're going to do is, in order to differentiate e to the x, we're going to start with f of x equals a to the x, where a is not equal to 1 and a is greater than 0. And this is the general exponential function, and we're going to look at the limit definition of the derivative for this. F prime would be equal to, which if we use the function a to the x would give us. Now, there's a property from algebra that says if you're adding an exponent, you can multiply like bases. So we're going to rewrite that as a to the x times a to the h. And then we notice that the a to the x factor is in both terms in the numerator, so we'll factor that out. Since the limit is taking h approaching 0, a to the x is remaining constant, so we can treat it like a constant and factor it out. So this is what f prime would be equal to, provided that limit exists. Now, there's a couple observations that we want to make about the derivative of f of x equals a to the x that are significant. First off, if we take f prime of 0, that's going to be a to the 0 times that limit, which would just be that limit, because a to the 0 is just 1. Second, this also tells us that f prime is a multiple of a to the x. If you look at f prime down here, it's based on a to the x times the limit. So in fact, the derivative with respect to x of a to the x is equal to f prime of 0 times a to the x. So if f prime of 0 exists, then f prime exists, and the domain of f prime is the same as that of a to the x, which is all real numbers. This is because the derivative is equal to f prime of 0 times a to the x. We know a to the x exists, its domain is all real numbers, and f prime of 0 would just be a number because that's the derivative evaluated at 0. And so if f prime of 0 exists, then you're just multiplying that by a to the x, so the derivative of a to the x would also exist. So the slope of the tangent line to the graph of a to the x at the point 0, 1 is equal to f prime of 0, and the value of that limit depends on the base a. So if we look at the number e can be thought of as the number for which the slope of the tangent line to the graph of y equals a to the x at the point 0, 1 equals 1. What that means is that if f of x equals e to the x, then f prime of 0 equals 1, and that would give us the following limit. The limit equals 1. And we have the graph right here of e to the x with its tangent line at the point 0, 1. Now, since the derivative with respect to x of a to the x equals f prime of 0 times a to the x, and if we let f of x equal e to the x, then the derivative of e to the x is going to equal f prime of 0 times e to the x. But we already know that f prime of 0 is equal to 1, so this is just 1 times e to the x. That just simplifies to e to the x. So here's our theorem. The derivative of e to the x is itself. I want to go over a couple things with you from a graphical standpoint. Here's the graph of e to the x, and I want to bring up a table of values for the derivative. Here we have a table, so I'm going to put in the x value. It's going to tell me the value of g of x and g prime. So we'll start with -2. Notice they're both the same. -1.5. Notice they're both the same. And if we continue this pattern, what we're seeing is we're creating a table of values for g and g prime, but notice they're the same. This confirms the result that we made algebraically, that the derivative of e to the x is itself. And notice that the points in black for g prime of x are lining up right with the graph of g of x, which is e to the x. Additionally, I can use Desmos to just graph g prime. And notice it lines up perfectly with e to the x. So this further confirms that the derivative of e to the x is itself e to the x. Let's go ahead and do an example. So we want to find the derivative of 4e to the x plus x cubed. So f prime of x is equal to 4 times the derivative of e to the x, which is itself, so 4e to the x, plus the derivative of x cubed, which we learned, bring the exponent down, subtract 1, is 3x squared. Now we want to look at differentiating y equals natural log of x. Previously, we learned that natural log is continuous on its domain, which is x such that x is greater than 0. Now, because we don't have the necessary mathematics to prove this rule, I'm just going to give it to you, but we will prove it later. The derivative of natural log x is simply 1 over x. So if you had f of x equals natural log x, then f prime is equal to 1 over x. Now we have to be careful because the original domain of natural log was x greater than 0. So the derivative 1 over x, it is only valid for x greater than 0. So let's go ahead and look at an example here. We want to find the derivative of 3 natural log x minus 5x squared. Pretty straightforward. It's just going to be 3 times the derivative of natural log x, which is 1 over x, minus 5 times the derivative of x squared, which is 2x. We could simplify this to 3 over x minus 10x. And there you have it, guys. Hope that was helpful to you. As always, reach out if you have any questions. Take care.